This video is related to parallel and perpendicular lines. So you've already seen how to graph a line and how to calculate slope and things like that. So there are some special properties for parallel and perpendicular lines. So parallel lines, what are those? They're lines that if they were to continue on forever and ever, they would never touch. So for example, those two lines there are parallel, and perpendicular lines, they're two lines that intersect at a 90-degree angle. Okay, so there'd be a 90-degree angle in there. So we can look at them graphically, or we can look at it algebraically as well. So how can we tell algebraically if two lines are parallel or if they're perpendicular, or neither, of course? So with parallel lines, you can see in the picture on the previous slide, the lines have the same slope. So lines have the same slope. Okay, and perpendicular lines will have what's called negative reciprocal slopes of each other. So negative reciprocal, which means you flip the fraction, slopes. So for example, for parallel lines, say I had the slope of a line was 5, then the slope of a line that is parallel to it, and some shorthand that I'll use for parallel. I'll use this for shorthand, parallel, and this for shorthand, perpendicular. So the slope of a line that's parallel to this line would be also 5. If my slope was -1/2, the slope of a line that's parallel to it would also be -1/2, so it would just be the same slope. With perpendicular lines, if the slope of my line is 5, then the slope of a line perpendicular to it will be the negative reciprocal. So I have to change the sign, which would be negative, and then I have to flip 5, so 5 is over 1, so it would become 1/5. Okay, if my slope was -1/2, the slope of a line perpendicular to that line, I would have to change the sign and flip the fraction, so it'll become positive, and 2/1, so +2. Okay, let's look at writing some, or identifying whether lines are parallel or perpendicular. So in the first one, are these lines parallel? So I just need to look at their slope. So I'm just trying to determine, do the lines have the same slope? So the first one is in slope-intercept form. I can pull out the slope really easily. I see that the slope of this line is -2. So I'll call this slope of line 1 is -2. And then the slope of my other line, this is in point slope form. So again, I can pull out the slope easily. It's right there. So it's also -2. So yes, these lines are in fact parallel. They have the same slope. And in the second example, are the lines perpendicular? So again, I just need to look at slopes. So the slope of my first line, again, it's in slope-intercept form, y = mx + b, so I can see my slope is here. So the slope is 5. So the slope of my first line, and the slope of my second line here, I have, again, it's in slope-intercept form, so I can pull out the slope is right there, -1/5. And since the slopes are negative reciprocals of each other, they are perpendicular lines. Okay, let's see how you would write some equations of lines. So we want to find an equation of a line that passes through the point 1, 3 and is parallel to this given line. So my first step is to find what would the slope of the line that I'm trying to find be. Well, I know it's parallel to this line, y = -2x + 7, and the slope of this line is -2, and since the lines are parallel, the slope of my line that I'm trying to find must also be -2. Okay, and then I know I have the point 1, 3, so because I'm given a point and slope, it's probably best to use point slope form, which you've seen in previous videos. So just to recall, that's y - y1 equals mx - x1, where my point is x1, y1, and m is my slope, so I'm just substituting the values in. So I have y - y1, which is 3, equals slope is -2, x - 1. So that would be one way to represent the equation of a line that's parallel to the line given and passes through the point 1, 3. Okay, let's see another example. So we want to find the equation of a line which passes through the point 2, 0 and is perpendicular to the line y equals negative 5 halves x plus 1. So again, the first thing I should do is identify the slope of my perpendicular line. So the line that I was given has a slope of negative 5 halves. So the slope of the line I'm trying to find will be the negative reciprocal of that. So it becomes positive, and I flip the fraction, so it's 2 over 5. And then again, I have a point 2, 0. So because I have point and slope, I should probably write my equation point slope form. I wasn't told to write my final answer in a certain form, but if you were, you could always just rearrange your equation to get there. So I have y minus y1, which is 0, is equal to my slope, and then x minus x1. Okay, and if I wanted to simplify it a bit, I can get rid of that minus 0, so I have y equals 2/5 x minus 2. Could write it like that, and even if you wanted to finish it off and write it as slope-intercept form, I have y equals 2/5 x minus 4/5. So there's my final answer in slope-intercept form, or you could leave it in that as well if it wasn't specified. Okay, that's it for parallel and perpendicular lines. Thanks for watching.